Ciao friends, and welcome to a new Unplugged video from SQL BI. In this video, I want to answer a question that appeared quite a lot of times on our article forums. The article is about how to show the top 3 products based on sales with an additional row that contains others. So the sales of the top 3 plus an additional row that accumulates the sales of all the other products. The latest technique that I have shown in an article shows how to do that in a Power BI matrix. People start to use the article that was quite popular, by the way. But a question that appeared a few times is how to slice by year. So I want to show the top 3 products, a row for others, and I also want to see the yearly sales of these top 3 products. It turns out that the code that I wrote in the article is not able to support such a scenario. Therefore, we are going to change the code in order to make it work, even though you want to slice by year, month, or whatever other column in the date table. I already played a bit with the code, so I know a bit about where to search for problems, because it is not going to be so easy. But it's a very good option to learn more about the details on how to investigate on problems and complex DAX code using DAX. Let's get started. First, the article. The article is this one, filtering the top products alongside the other products in Power BI. I'm not going to read the article in detail, or maybe just stop for a second on the result. The result that we want to obtain is a report like this that shows the top 3 products, so you define 3 here, and the report shows the top 3 products plus an additional row that contains the sales of all the other products. You see that in this matrix I'm not slicing by year. Now, among the comments, I guess it's the last one. Where is it? Here it is. Oh, that says, when I added calendar year to the columns in the matrix, it breaks the top end. And he's right, the code is not working. There is a further discussion here, but the problem is slicing by year. So let's go straight to the demo and see where the problem is. The demo is here. This is the same file that you can download from the article, and I want to add the year here. Before starting to work on the article, on the matrix, keep in mind that there is a hidden column, and that contains the ranking that is needed in order to sort and place others at the end. This ranking column is hidden, so typically the report shows this way, but it is there, and that is going to be very relevant later as soon as we start playing with the code. Now I want to add a column, so I need a bit more real estate. Let me get rid of some entities. Let's get rid of this. I also want to get rid of this slicer, so I place the brand in a filter, and we filter the same brands, so we want ADATUM, AdventureWorks, Contoso, and Whiteboard Importers, so that now we can get rid of the slicer and have a bit more space. Let me see whether it's readable, or we should increase the font a bit. Let's go by 17. That's a bit too much. Okay. Now you see that the ranking column is here, and it's used both for the sorting, so to show others as the last row, and the ranking is also used in the visible row. Visible row is a specific measure that is needed in order to hide rows that are not interesting. Visible row, we can quickly look at the code of visible row, uses the ranking measure. So the entire solution that we built is based on the ranking measure. What happens if I add the year here? We can go search for the year, drop it in the matrix, and something strange happened. the year on the columns in the matrix. Let's reduce the filter pane. And it's not working. You can see that because we have 1, 2, 3, 4, 5 rows under cameras and camcorders, even though the top end should be 3. And the problem is that we have this row that is fine. It has a ranking of 3. This has a ranking of 1. And then this has a ranking of 2. This additional row, 8-atom SLR camera, doesn't have a ranking in 2008. The reason why it is shown is because it has a ranking actually in 2009. It is ranked 2 in 2009, even though it is not ranked in 2008. And here is the problem, the first problem that we need to face. That is, define what to do and what to show. Because when we say that we want the top 3 products and we slice by year, what do we mean by the top 3 products? The top 3 products each year, which is what it is, what the measure is showing right now, or apply the top 3 over all time and then show me the yearly sales of products of the top 3 products over all time. Out of those products, show me the yearly sales. And I guess people want to do that. They want to compute the ranking at the grand total level and then use that as a filter in order to show the yearly sales of these top 3 products. Therefore, what we need to do is avoid having a ranking that is computed year by year. You see that we have values here, we do have values here, and these are different than the values at the grand total. Actually, at the grand total, this product is not even ranked. So we have 1, 2, and there is probably 3 is this row. So I should not see this additional row in the report. In order to make it work, what we need to do is change the behavior of the ranking measure. That should show a value here, an identical value here, and again an identical value here. The easiest way to solve it is to get rid of the filter from the year when we perform the ranking. So we can do that quite easily. We go in the ranking measure. Okay. That way is readable. Ranking computes the products to rank. Top end value is 3, the 3 products that I want to rank. Sales amount is the sales amount of the current product that needs to be ranked, and it will be ranked here. In this rank X, you see that we use sales amount as the value. Now this needs to be not the sales amount, but calculate sales amount, and we get rid of the filter from the date. Actually, we can get rid of the filter from the date entirely. So now we have the sales amount that computes the grand total of sales based on the year, and we also need to do the same here. In rank X, we are going to do the same and maybe format the code in a better way. Therefore, we compute, no way, it doesn't go away. We compute the sales amount of the current products regardless of the date. We compute the visible products as calculate table values of product or selected product name. Also here we need to get rid of remove filters from the data, just in case there are products that are visible in different years and not in the current year specifically. And for the ranking, we do the same. We rank out of the visible products the sales amount at any time, and we rank the sales amount among those values. Everything else should be correct. So let's give this a first try. Now we have 1, 2, 3, 4, which is fine. 1, 2, 3, 4, which is fine. And we have 1, 2, 3, 4, that is fine. So it looks like we already solved the problem. Actually, well, we should probably reduce harder than expected. Okay, reduce the width of the ranking so that it shows the correct report. Now, that works fine, but the thing is, we are not entirely sure that it's working because here we have a filter 2008 and 2009. The ranking of these products is not only using 2008 and 2009. The ranking of these products is based on the entire period. Whereas if I place a filter, for example, only on 2009, I would like to see products, the ranking only based on 2009. And it's pretty clear here that these are not the top sellers because these values are so small compared with others that these are not the top 3 sellers. They are the top 3 sellers over all time, but not only in 2009. And I placed a filter using a slicer for only 2009. So what I would like to do is to consider the slicer during the calculation of the ranking to consider 2008 and 2009. That requires us to avoid using remove filters and instead use all selected. So instead of using remove filter to get rid of any filter from the date, we will use all selected on the date to restore the filter that is present on the year. And we can do that again. On the ranking measure, instead of remove filters, we can use all selected. And we need to do that here and here and here again. Now you see that the numbers are very different. We can also enlarge the ranking measure. That should be here and here. We have 1, 2, 3. Others is there because we are no longer sorting by ranking. Now we have 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. But this product should not be there. So Contoso SLR camera should not be here because we have 1, 2, 3, and we have this fourth product that doesn't make any sense. So let me simplify this a bit. There's something weird happening. This row should not be present. And it was not before. Let me check it again. So let's go back to ranking. If we have remove filters, and remove filters, we have 1, 2, 3 products plus others. Let me get rid of cameras and camcorder of the category because that way it should be a bit simpler to read. Now we have 1, 2, 3 products plus others, and the value for ranking is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, as I would like to see. But if instead of using remove filters, I use all selected should restore the filter, and looks like it doesn't work. Indeed, you see we have now 2 products, 1, 2, 3, 4, 5 products instead of the 3 that I want. And these products do not have sales amount, they do not have a ranking, but still they are shown here as soon as I start using all selected, which is very cool, meaning that the code is not working and we need to understand what is happening here. We could, let's check the condition. The condition is that visible row is not 0. We have a filter on category and a filter on brand. Let's get rid of the filter on category too. Now we have 1, 2, 3. Now it looks like it's working. And if I get rid of the filter from the brand, it's even worse. So let's go back. Okay, with the filter for the brand and a filter on category. So we have 1, 2, 3, 4, 5 rows. We need to understand why these 2 rows are visible, even though the condition visible row is not 0 is there. So a good option is to add visible rows, so we see first of all their value. Visible row is blank, and we have 1 and -1. So that is kind of strange, because you see that visible row is blank, so it's like 0, and it is not visible. The rows are still visible, so there should be some reason why the value computed here is not used as a filter, because I should not see these 2 rows at all. I should only see 1, 2, 3, 4. And when this happens, what we need to do is to investigate further. So let's get rid of visible rows just to simplify the query a bit. And we can use the performance analyzer to grab the query and try to understand what's happening. Let's refresh the visual, go to the matrix, copy the query, and then we use DAX Studio to investigate further. Okay, let's paste the code, format it, and it's quite complex. But we need to start from the beginning. We have this variable that contains a filter for camera and camcorders and computers. That is a filter we placed in the filter pane. Then we have a filter for the brand that again we placed in the filter pane. We have the filter on the year, that is a slicer. Let me just check that. Let me move this on the other monitor. So we have a filter on the year, a filter in the filter pane on category and brand. Visible row is used in a different way, because visible row is a measure, therefore it will be used with a more complex query. But we have a filter on category, filter on brand, and filter on year. Then we have this other filter that computes the top n for 3, and again this filter is coming from this slicer, so it's filtering the top 3. And then we have a first query, value filter constraint DM1, that summarizes products by product name, year, year number, using those filters. Now, a thing that I like to do when I have code like this that is quite complex, let me copy everything, is to use tabular editor to rename some variable, because that makes the entire code much easier to read. So I just launch tabular editor, and we have it here. Window, I want a new query. So we have this variable that is filter on categories. This variable is a filter on brands. Let's get rid of on, filter brands. This is filter years. And this is filter top n. The reason I'm using tabular editor is because you see that I can rename a variable, and this renames the variable everywhere. That makes the code so much easier to read. But still, when it comes to run the query, I just copy everything, go back to DAX Studio, because DAX Studio is a bit more user-friendly, specifically to increase the result size. Now, so far we have only slicers. Then we have another variable, value filter constraint dm1, that summarizes product by product name, by year and year number. Year and year number are used because we are sorting year by year number, and it's placing a filter categories, brand, years, and top n, which are the slicers, and it's computing the sales amount, the ranking, and the visible row. Okay. Let's see the result of this. We can get rid of everything here. We can always retrieve it if needed. Okay. This is retrieving product name, year, year number, sales amount, ranking, and visible row. And it's only retrieving values where sales amount or ranking or visible row are not blank. Actually, it's retrieving values where sales amount or ranking are not blank. It's ignoring visible row. So despite visible row being blank or not, this table will contain only... This table contains all the combinations of product, year, year number, where either sales amount or ranking is not a blank. Then this variable is used here. But before anything else, I want to focus on the problem. And to do that, we know Contoso projector 180p is the column the row that we do not want to see. So we add the filter here. A filter out of this where product name, it's actually product name equals Contoso projector 180p x981 silver. It doesn't work. Why? A single value for product name in product. How is this column name? Oh, product names, product name. Okay, let's copy it. Okay, we have product name, year, year number, sales amount, ranking is blank, visible row is blank. Therefore, this row, despite having a value for sales amount, should disappear from my matrix. So clearly, this variable is not yet computing the filter. Indeed, you see there is no filter anywhere here. This is only computing the combinations of attributes that I placed on rows and columns that produce a non-blank measure. And then, as we said, this variable is used here in another query that filters a summarized column by product name, applying these filters, which are the slicers, and my variable. So I compute a list of values here, this list, and I use it later in value filter dm1. So let's investigate on the content of value filter dm1. And that is kind of weird, because in value filter dm1, visible row is 1. Visible row that we computed a few seconds earlier Let me have both. So in value filter dm1, the result is 1 for visible row. But in value filter constraint dm1, visible row has a blank. And it's the same product. The only difference is that we do not have a filter on the year in value filter constraint. No, we do have a filter on the year in value filter constraint, and we do not have it in value filter dm1. And the value filter dm1 is where I actually place the condition visible row different than 0. So if I look at value filter dm1, the condition visible row different than 0 is actually true, because visible row is 1. The thing is, how is that possible that in value filter dm1 I obtain a different value than what happens in value filter constraint? Let me check it again. I know I'm repeating myself, but in value filter constraint, the visible row is blank, and value filter constraint is used to filter value filter. In value filter, the result is 1. So that row is visible. Why that? We need, let me add the definition of the ranking. Define measure, so we also have the ranking measure here, and we can reason a bit on top of it. Ranking is computed here. No, not ranking, visible row, sorry. But visible row is here, and visible row basically depends on ranking. So we could investigate on visible row, but actually we can tweak it and look at the ranking. Let's see what happens if I add the ranking here, or we can actually add it as another column, ranking here and here. Oh, I have ranking here already, just me being blind. I have it there and I want it here too. Now, in value filter dm1, ranking is 2 and visible row is 1. That is correct, because a ranking of 2 makes the row visible because we want the top 3. Whereas in value filter constraint, the ranking is blank and visible row is blank. So again, the problem is in ranking. For some reason, the value of ranking computed in the value computed in value filter dm1 is correct, because remember that we do not want to see this row. So this row should not be here because its ranking is actually a blank. The problem, therefore the error, is when the ranking has a value. So not in value filter dm1, but in value filter constraint. Not in value filter constraint, but in value filter dm1. This is where we have a problem. So the problem is here in value filter dm1. We compute the ranking here. We have a filter on the product, on categories, brands, years, top n, plus my value filter constraint dm1. And the only thing that I changed is this all selected date. Now, what does all selected do? All selected, when used in summarized columns, removes any filter from the group by columns, and it restores the original filter that was present when summarize column start its execution. That includes external filter context plus the filters that have been added in summarize columns itself. So if we have a problem, it's likely to be there. Here, the filter contains product name, which is not interesting because we are using goal selected on a date, categories, brands, years. This is relevant. Now, filter years contains 2008 and 2009. 2008 and 2009. And then we have filter top N, that is not relevant, and value filter constraints DM1 that actually contains the year. It contains the year, and let me see what is in there. It contains only 2009. So here we have only 2009. Therefore, this filter and this filter, they are working together, and only 2009 survives the filter. That is why when ranking is computed for Contoso project, that will compute the ranking in 2009 only. And the ranking in 2009 should be 2. We can actually check that. Let's go back here. Contoso projector 180. If I get rid of this and I only filter 2009, the ranking 2 is Contoso projector 180 X981. Let me see if it is actually the product X981 silver. So we are computing the ranking in 2009 only instead of computing the ranking over all time. And that is our problem. So using all selected here restores the filter placed on this column together, on this filter and this filter together, making visible only 2009 for the special case of this product. So it's likely if we have products that do not have sales over the entire period, for those products the ranking will be inaccurate. Why is that? Well, basically because of this ignore. Because we are not considering rows. Well, because actually, no. Because we do not have neither ranking nor sales amount in 2008. So let me try to recap. This value filter constraint DM1 creates a filter for only the rows that have a value for sales amount or for ranking, which are the two measures that we placed in the matrix. If we look at the matrix, you see that we have in the matrix the sales amount and the ranking. It's really hard. Okay, so these two measures that are used in the matrix are used to define the content of value filter constraint DM1. Because our culprit, the product that is suddenly visible, does not have neither sales amount nor a ranking in 2008, then we don't see it. Let me go back here. Indeed, my product does not have sales amount, neither sales amount nor ranking in 2008. It has a value in 2009. It doesn't have a ranking, but it has a value. And it doesn't have a ranking because this is computing the ranking of all time. It's the ranking computed inside value filter constraint that is wrong. So what we need to do is to force value filter constraint to contain 2008 even though the product does not have sales. We cannot force sales amount to be a non-blank value, but we can force the ranking to have a non-blank value. So if I change a ranking to say that if it is in scope, products to rank, blah, 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 then we compute the ranking. If the ranking is greater than 0 and less than products to rank, the ranking. Otherwise, let's return minus 100. Now, because ranking will have a value for all the years and all the products, I should see 2008 here. If I run it, that is good, but why do I see minus 100 twice? Before it was blank. Yes, before it was blank. Now instead of being blank, it shows minus 100, which is good because it shows 2009 and 2008. Now I have both 2009 and 2008 in my filter top n, so I will have 2008 and 2009. Therefore, I would expect value filter dm1 to compute the correct ranking. That should be minus 100. Actually, no, because we have this visible row different than 0. If we remove the condition, we have a ranking of minus 100. So in order to force the correct calculation in this value filter dm1, we needed to tweak ranking so to show a value even in scenarios where it wouldn't. So we are basically getting rid of an optimization of the engine. Power BI engine uses the first list to reduce the number of products that it will scan during the next calculations. And it does it in order to speed up the calculation. But doing that, it also includes the year. And because the year is the column that we are using, for which we are using all selected, that filter on the year, that is an arbitrarily shaped filter, conflicts with our all selected. So the filter on the slicer and the arbitrarily shaped set created by Power BI, they fight each other, reducing the number of years that are visible for some products depending on data distribution. By forcing the ranking not to be blank, because ranking is used in the visual, then we are now computing the ranking correctly. We need to check that this code is actually working, because now ranking returns minus 100 if we tweak it this way, and we need to get rid of it. Now let me go to Power BI. Power BI is based on visible row that checks that visible row is not 0. So actually we could return 0 instead of blank. Let me see if we use 0 here and we run it, ranking is 0. And because visible row checks that ranking, no, let's check visible row. Visible row checks, where is my visible row? I don't have it anymore. Okay, visible row computes the ranking, check that it is not blank, it is less than the top value, or equal the top n value plus 1. So under this condition, the ranking goes 0 should not be visible. And if we run it, visible row is 1 and ranking is 0 because here we check, sorry, invisible row, I lost it, we check notice blank. That should be ranking different than 0. So we take into account also 0. And now the product disappears. So now we can try to do the same here. We need to change ranking and return 0. That is needed because we want the row to be present in the filter. And as a consequence, I see everything because now the ranking is always 0. But now we can change also visible row and check that ranking needs to be different than 0. Now it's behaving. Now it's showing 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I can remove my ranking column. And now it's working. I filter 1 year, 2 years, 3 years. I don't want to see this ranking. And now, not having any filter on the year, these are the top 3 products over all time, and these are the sales amount in 2007, 2008, and 2009. So, not that simple. We had to change several pieces of the code. And I always tell to all of my students that all selected is a complex function. It's really complex, even because all selected uses shadow filter context when you use it in summarize or in normal calculation, but in summarize columns, its behavior is slightly different. Semantically, it's very close, but slightly different. And in scenarios like this, they really drive you crazy. Anyway, I'm quite happy because we made it. We now have a version of the code that works in a nice way. So, time to draw some conclusion. As you have seen, it took us a while to understand where the problem was with all selected. If you go for the remove filter solution, that is going to work, but it's not dynamic. It's not really a nice measure because it does not behave correctly in all the scenarios. As soon as we started using all selected, then the problem started to appear, and we had to dig into the details of how the DAX code is executed. What we discovered is basically that we do have a difference between how values might be computed. Values are computed when you place a measure as a filter in a matrix in 2 different steps. One to define the rows that needs to be used for the calculation, and then another step to actually filter the numbers. That is likely to be an optimization of the engine, but we need to take that into account. So in this specific scenario, changing the ranking measure had been enough, and we have been able to fix the problem. But I think the topic by itself is kind of interesting. So I probably plan to spend a bit more time, build a simpler reproduction of the same scenario, and write an article where I discuss the topic a bit better, and maybe make a video where instead of playing with code and trying to guess, I just describe what is happening, so it will be more educational video. This was just an unplugged, so you always see exactly what is happening when we investigate on the code. I hope you enjoyed watching the video, and as usual, enjoy DAX.